Hi everybody, in this video let's learn how to find the perimeters of a segment of a circle. Okay, now I have a circle over here. This is minor segment which is less than half. Okay, and this part is major segment which is more than half. Major segment, minor segment. So if the questions ask us to find the perimeters of a segment, so how do we find that? Okay, let's focus on this minor segment here. If I ask you to find the perimeters of this minor segment, you know that you need to take this length, which is the arc length of PQ, plus this length, which is the chord length PQ, right? To find the arc length, I think you have no problem. S equal to R theta. The theta is in radian. So if the given angle is in degree, you actually can use another formula which you learned before, 2 pi R times theta over 360. So if you use this formula, the theta will be in degree. So now, how about the chord length PQ here? Chord length PQ. So before I show you how to get the chord length PQ, let me explain to you about this one. This you learned before actually. I hope that you remember. If you have a circle and the radius cut the chord and form a right angle, the length here, okay, let me give some letters A. This is O, this is A, B, C. The length AB will be equal to the length BC. Okay, I hope that you still remember this. Now I'm looking for the chord length which is AC. So if I'm able to get the length of BC, then I will be able to get the AC, right? I just take the BC times 2, then I get the chord length from A to C. Okay, let me draw two ray lines first. Okay, now here you see two right angle triangle, OBA and OBC. So triangle OBA and OBC, they are congruent, exactly the same. So if AOC is theta, the angle, okay, let me write over here, angle AOC is theta, angle COB or angle BOC will be equal to theta over 2. This is theta over 2. Here the same thing, theta over 2. Okay, now let me explain to you how do we get the chord length formula. Let's focus on this triangle first. Okay, now you understand why it's theta over 2, right? I want to find the chord length PQ, but it's okay. Now I just focus on PN first. Once I get the length of PN, I times 2, I will get the chord length PQ. Do, ka, so. Tangent is equal to opposite divided by the adjacent. Opposite side divided by the adjacent side. Cosine is equal to adjacent side divided by the hypotenuse side. And sine is equal to opposite side divided by the hypotenuse. Okay, now I'm going to use sine here. Sine, this angle, which is theta over 2, is equal to opposite side, which is PN, divided by the hypotenuse. So this is right angle. So the right angle is over here, hypotenuse will be over here, which is the radius of this circle. Both sides I times R, the R will move over here, and this time R, I will get R sine theta over 2, and here I times R as well, the R will actually cancel out. R sine theta over 2 is equal to PN. But now I'm not looking for PN, I want PQ, right? So as I told you just now, PQ is actually 2 times of PN. I just take this one times 2. 2R sine theta over 2. Okay, so this is the formula that we can use to help us to get the chord length. Now, we got a formula to find the perimeters of a segment. Perimeter of a segment is equal to r theta, which is the arc length, plus 2r sine theta over 2, which is the chord length. So if you want to do the factorization, you actually can factorize r, then become this one. Personally, I would suggest you to remember this one instead of this, because if you remember this one, you are very clear. This is for chord length. This is for chord length. And this is for arc length. Okay, perimeter of a segment is r theta, arc length, plus 2r sine theta over 2, chord length. Okay, now let's try a few examples. The diagram shows a sector with center O. Okay, this is the center of the circle. Find the perimeters of the shaded segment. So it means that we want to find the length here plus the length here, right? So this is r theta. Okay, let me write over here. This is r theta, and the chord length is 2r sine theta over 2. Okay, so at the beginning, I would suggest you to write the formula for a few times so that you can remember the formula well. Parameters are perimeter of the shaded segment is equal to r theta plus 2r sine theta over 2. Okay, so if you want to convert the theta to this theta must be in radian. Okay, this theta must be in radian. This theta can be in radian or degree. So, but when you key in your calculator, you have to be more careful. So here, I'm not going to convert the data here to degree. I will use radian over here. So, but when we key in our calculator, we have to be more careful. R is a radius, which is 5. Theta, which is this one, in radian, remember, 0.86, plus 2r, radius, sine theta over 2, so it's 0.86 over 2 radian. So if you do not convert it to degree over here, when you key in your calculator, you have to be more careful. Okay, so this part you should be no problem. 5 times 0.86, 5 times 0.86, you get 4.3. Okay, how to key in this part? Let me show you my calculator over here. So now I'm going to key in this part. 2 times 5 times sine. Okay, since I do not convert this to degree, I just press 0.86 over 2. But you have to be careful. If you key in like this, you press equal, the calculator will just assume 0.43 degree. You have to tell your calculator that this is radian. So how to do that? You press this option, angle unit, press the second one, number 2, which is for radian. Then you will see a small r appears beside this 0.86 divided by 2. Now your calculator know that this angle is actually in radian, not in degree. Press equal. Okay, let me read again. 4.1687. Okay, then just plus them together. (8.4687 centimeters). If you don't want to give 4 decimal places, make sure you give your answer in 4 significant figures, which is 8.469. Okay, this answer also can be accepted. So just be more careful when you do not convert it to degree. Remember, when you key in your calculator, remember to key in the radian here, so that your calculator know that this angle is in radian, not in degree. Okay, now let's look, try these questions. Another questions. The diagram above shows a circle with the center O and the radius is 7 centimeters. Given the length of chord AB, so the length over here, AB. Okay, let me use a highlighter. AB here. This is a chord length, 7 centimeters. Find the perimeter of the shaded region. We know that if you want to find the perimeters of this shaded region, we have to take this chord length, which is 7 meters, plus the arc length, right? AB. How to find the arc length? You know that to find this arc length is r theta. The theta is in radians. S equal to r theta. The theta is in radian. Or S equal to 2 pi r times theta over 360. This theta is in degree. So we have the r, which is 7 centimeters. The problem is we don't have the theta. So the first thing is to find the theta first. What is the size of this angle? How do we get the chord length? Still remember just now what the formula for perimeters of a segment. You know that is r theta plus 2r sine theta over 2. So if you remember this formula, it's very clear. This is for arc length, this is for chord length. So you know 2r sine theta over 2 is actually equal to 7, right? Which is the chord length. So our job is to get the theta. But when you press your calculator, you have to be more careful here. 2, we just keep it as 2. What is the r in this case? Which is 7 centimeters. The radius of this circle, 7 sine, this is theta over 2, is equal to 7. So sine theta over 2 is equal to 7 divided by 14, which is equal to 1 over 2. Okay, so until this step, you have to be more careful. How do we get the theta here? Here it's not theta, but theta over 2. Be careful. We want to get the angle, right? So we have to find the anti-sine of 1 over 2. So you have to remember to press the shift first, then press sine. You get the symbol 1 over 2. Okay, this angle is in degree, not in radian. This is degree, 30 degree. Theta over 2 is equal to 30 degree. So theta will be equal to 30 times 2, which is 60 degree. Now we know that here is actually 60 degree. So the next thing is to find the arc length, right? AB. If you want to convert this to radian, yes, you can do so. Convert this to radian first. Let's say 60 degree. Okay, let me write this one for you first. Pi radian is equal to 180 degree, right? Degree to radian, number becomes smaller because this pi is just 3.14 something. This is 180, so number becomes smaller. Degree convert to radians, number becomes smaller. Small number on the top, bigger number at the bottom. So it will be radians. Just press your calculator. Okay, 1.0472 radian. Okay, so the r theta, which is arc length, right over here. R theta is 7, theta is 1.0472. So I will get 7.3304 centimeter. So let's say if you don't want to convert it to radian, you also can get the answers. You use this formula. Okay, let me try. 2 pi r times 60 over 360. Okay, you get the same answer as well. So let me show you here. Arc length AB. I don't want to convert it to radian this time. I just use the angle in degree. 2 pi r times theta over 360. So do you notice that this is a degree, this is in radian. Okay, just press the calculator, you get the same answer, 7.3304. But this is not the final answer yet, because the question is asking you to find the perimeter of the shaded region. Okay, let me write over here. The perimeter of the shaded region is this chord length, which is equal to 7 cm given by the question, plus the arc length AB, which is 7.3304, 14.3304. So actually you don't have to give so many decimal places. You can just round off it to 4 significant figures, which is 14.33. Okay, that's all for this video. Hopefully you understand better about this parameters of segment. See you next time. Thanks for watching. Bye bye.